All right, 4-6, and this is on page 228. So you've heard of probability and odds many times before. Probability and odds. So we're talking about two similar yet distinct ways of measuring what? What in the world is probability used for, or what is it? Can anyone kind of help out with that? What's probability? Yes? Yeah, how likely something is to happen. That's dealing with probability. Does anyone know what the odds are? It's related, but not the same. That's why we're going to split into two. What are the odds?
The chance of something.
So probability and chance go hand in hand. One's in fractional form, one's in percent. Odds are a little bit different even than that. Yep?
They're not even numbers.
They're not even numbers. What do you mean by that? You mean
Like odd numbers.
Gotcha. Thank you, Jess. So not the evens, the odds. I guess odds is going to be this, and I'll write it up on the board in a bit. Odds are going to deal with the chances of getting something to happen, the successes, versus the failures, okay? And I'll give you examples of how that works. Probability, though, we're going to write this down. The probability, so I had to switch because that gray is kind of light. Probability of an event, okay? So this is what we're talking about, the likelihood of something happening. And we're going to go with simple probability. This is not complicated. It gets complicated. Very, very, very complicated. Where you're getting like all these formulas and algorithms to figure out the probability of me winning the lottery on Thursday with those numbers. You can calculate probability, but once I get you the probability of something happening, we're going to talk about what that means for me as a human and what that actually is in God's perspective, because it's different. It's not the same for both of us. All right, so what is the probability of an event happening? All right, this is the notation for probability, capital P, and then parentheses, you put what you want to happen or what you're measuring. So the probability of an event. Okay, and this is the ratio. It's the number of favorable outcomes. The number of favorable outcomes over, because I said it was a ratio, so it has to be something compared to something else, the number of favorable outcomes compared to the number of possible outcomes. I'll get out of the way in just a moment. All right, there you go. So write that down. That's super, super important because that's different from odds. It's not the same. Number of favorable outcomes over the number of possible outcomes. So the probability of something happening, there are a number of likely, or a number of successful over the number of possible. So let's look at a simple probability problem. Look on page 230. You're going to have to turn the page once. And these are the problems you're doing. They're not very hard, but they do get progressively tougher. These are the easiest ones. All right, look at number 7 on page 230. Determine the probability of each event. Okay, so this is number 7, the probability of this event happening. Okay, what's the event?
The coin will land tails up.
Okay, the coin, you flip it or you toss it, whatever you do, and it lands tails up. Okay, it's going to be the probability of tails. So you're trying to get the probability of tails landing, or you can put T. All right. So I have to think of what are the two numbers I'm comparing. How many possible outcomes will you get when you flip a coin? Possible outcomes. Yeah, don't say 3. It's 2 if it's a fair coin. 2, right? You're either going to get a heads or a tails, right? Okay. So 3, they're like, if it lands on its side, well, it's not fair. Or we just do it again because no one does that. And maybe in the grass, like in a football game, it might land. I don't think it does anyway, but we'll say 2 chances, 2 things, heads or tails. If you're looking at the probability of getting a tails, how many favorable outcomes with that one toss? 1. So we say the probability of getting a tails is 1/2. How many of you have heard that before? It's not hard. It's 1/2. 1 favorable over 2 possible. That's it. What's the probability of getting heads? It's still 1/2. We would say that probability of getting a tails versus the probability of getting a heads is equally likely, isn't it? That's why we do that. And there are technicalities. Yes, one side could be heavier than the other because of the design. Or maybe the residue that's left behind. I don't know. There are a lot of variables. But we tend to say it's a fair coin. You flip that coin, you're either going to get heads or tails. Unless it's two-faced and it's both heads and you lose. Anyway, go ahead.
You know how you said like if it lands straight up?
Like on side.
On like grass or something, wouldn't the probability of landing it straight up be smaller than the probability of landing it on two other sides?
Yeah, you can think of it that way. If it's possible for it to land straight up like in a crack, then it's very low that it's going to happen like that. More likely go this or that. Yep, that's it.
Would it be a probability instead of a probability?
The probability of no, because you're going to consider it the probability of falling into a crack. So that would be one favorable out of, and then that's where you get advanced. You got to come up with an algorithm. How many times has ever done that, and how is it likely to happen? You could do it mathematically with physics, how it lands on the ground, how many bounces it takes, and you can get very technical. It's just advanced probability. Yeah. Yeah, which is really cool. Anyway, 8. 8. What is the event? Find the probability of each outcome if a die is rolled. So a die is one out of 2 dice. You know how you have a die? You call it just one die. So what's the probability of getting a 6? Well, we say the probability of getting a 6 is equal to, Josh, how many successful or favorable outcomes are there? There's one. It's just a regular 6-sided die. How many possible outcomes are there? 6. So, what's the probability of getting a 6 on a single roll? 1/6. Right? That's it. Okay, if you think this is easy, this is good. Because it will get different with the odds. Not harder, but just different. And then I hope you guys can pick up the differences quickly. Oh, sorry. Yes. Walker.
I got 16.6 repeating on forever percent.
Gotcha. You're starting to put them into percents, which I would put as a 17, but 16.6, yeah. You can put them as percents, but not for the homework. I need you all to put fractions because those are going to give me exacts. Probability is usually measured in fraction. Chance, percent. Odds, ratio.
So for 7, did you get 1/2?
Number 7, you get 1/2. Yeah, you said 50%?
Yes.
Which is the 50% chance of it being a tails. Yeah. Josh. No, I'm just trying to do that to help you to see what it's going to look like so you know what that even means. No, you just gave me the fraction, which, again, these are not that hard. Number 9, a number greater than 2. So you roll a die. What's your probability of getting a number greater than 2? So the probability of getting a number greater than 2. So I could just write that down. How many possible outcomes? 6. It's a rolling of a die. 6 possible outcomes. How many favorable? So how many of those faces are going to give you a number greater than 2? 4 of them are. And just like with most problems with fractions, do you think this is my answer? No, you have to do what to that fraction? Simplify it so it becomes 2/3, which is 67%. So your probability of getting a number greater than 2 is 2/3. So high or low? What do you think? I think it's high. Yes, sir.
When you put the probability down, like I see you're just simplifying it, but in these kind of problems, wouldn't that be changing the probability because it's saying, or is it just?
Okay, so here's how I'll put it because I think I see what you're saying. You're saying for every toss, every single toss, 2 out of the 3. Sorry, your likelihood of getting a greater than 2 is 2 out of 3. Or if you're thinking like Walker, 67%. 67% is going to be, rolling 3, 4, 5, or 6. So it doesn't change whether you set it like that or like that. It's still 67%. But we just want to see it in simplest form so that we could, if we wanted to, get a percent quickly. Yeah. All right. Probability. What a strange thing. You know, if I had a coin, I didn't bring a coin. But if I had a coin, yeah, I was here, throw coins at me. Yeah. Oh my. I will not flip water balls. But anyway, if I had a coin, You know what would happen? What could possibly happen? It's this. I flip the coin, and it lands heads. And I'm like, okay, this is a heads table. That's like, I got to move to another table. So I flip it, heads. Oh my goodness, wow. And I come here to Beth's table, and I'm like, flip it, heads. Oh my goodness, what in the world? And then Owen, it's got to change, right? Flip it, and it lands heads. What's the probability when I come here to Kendall's table and flip that coin that's going to land heads? Wait, I thought it's 100%. Okay, no matter what happened in the past, the probability of it landing heads that next time has got to be 1/2 or 50%. So it is independent of what happens in the other problems, okay? But we will get to more complicated probability, where what's my probability of getting 3 heads in a row? See, and that's where you can start using these a little bit more detailed, in more detail. Okay, but anyway, I want you to look at example number 1, and this is where it gets just a little bit more involved. Not too much, I hope. How many of you like Scrabble? You guys like playing Scrabble? I used to love playing. I haven't played in a long time. I want to play. I had my most valuable word was when I was in high school, and I was playing against the English teacher, and he was just owning us, boom, boom, okay. But I had an N, a Y, an X, and an O, and I had an opportunity for a triple word score. So I had a word, and I was thinking, this got to be, no, there's nothing. This is N, Y, X, and O. Really? That's terrible. And then plus some E's and A's, which never helped me. I got to win this. Got to do it. Onyx. Onyx landed perfectly on the triple word score. And I think it was like, I don't remember the point values, but it was, Y is Y rare? I know X is rare. N is fairly. Y is pretty good. O is not that great. But a triple word score, I only lost by 200 points that day. That was like, he was started beating us like 300. And I got like a nice. I was proud that day. That was my word. That was it. Okay, onyx. Yeah, it's a type of stone or rock. Stone. I've heard onyx, and I don't even know what it was, but I knew it was high. Yes, ma'am. It's possible, but yeah, the onyx gave me the high point value. Thankfully. Well, she's saying you could have used like the other ones and left out the Y, which was okay. Okay, but anyway, thank you guys for your. I need that triple word. I need as many high letters as I can to make this respectable. Okay, example 1. Lauren is representing her sophomore class in a word board game tournament. She is the first player to select her 7 tiles out of the 100 available tiles. The distribution of tiles is shown at the right. Find the probability of each selection. All right, I'm looking at the table there and like, what are they trying to say? Okay, look at the top row. J, K, Q, X, and Z. How many of those are there in that board game? 1 each. There's 1 J, there's 1 K, there's 1 Q. And then how many A's are there? 9 of them. How many T's are there? 6, I believe. 6. How many E's?
12.
Which was the most likely? The E, right? So getting an E is the most likely. Getting which ones are the least likely of getting? Okay, so you can kind of see that even the blank is more valuable than not more valuable, more likely to happen than a Z, X, Q, K, and J. Blanks are nice, by the way.
Oh wait, no, blank is actually a chip.
Yeah, so you get a blank chip, and you can use whatever letter you want, which is very nice. Oh, yeah, I know, the strategy there. Yes, the maker of Scrabble. Thank you for that. Okay, what's the probability of getting an O on the very first selection? So the probability of getting an O is going to be a fraction. How many possible tiles? She's the first one to pick her 7 tiles. What's her probability of getting an O? Well, how many possible tiles are there? How many? It says it. 100. There are 100 of them total. How many O's are there in that? 8 of them. So those are favorable. She has 8 favorable outcomes, 100 possible outcomes. And then you guys know, percentage-wise, that would be 8%. But as a fraction, what would it be reduced? 2/25. So I want the 2/25 for your answer.
Not going to get one.
Sorry?
Honestly, you're probably not going to
Yeah, it's low. And here, where I'm going to get to something here with probability. I'm still going to get there, what it means to me and what it means to the Lord, how that actually works out, and then practically what that means. But 8%, yeah, not very high. B is a little bit tougher. The odds, I'll tell you the odds, because the probability, I don't think I've looked at the probability, but the odds, which actually, I guess I could find out very quickly, but we'll see the relationship. I'll look it up real quick, because it changes. It like changes every day. Like, yeah, they change it up.
Yeah, and it keeps going down.
Okay, anyway, B. What's the probability of getting an E if 5 tiles have been selected and 2 of them were E's? Okay, that's tough. The probability of getting an E. So we got to read that question carefully. All right, are there still 100 tiles left? No. How many tiles are left? 95 of them, because they said they took out 5. And then how many E's are on? Or how many E's are available? 10. Wait, it's 12. It says 2 of them were E's when they took them out, so 10 of them left. 10 out of 95. Okay? So, reducing this as a fraction, I would get 2/19, which would be about, what percent you guys think? Yeah, about 10%. So I'll put here approximately 10%, just to give us like, oh, okay, good. So probability, not that high, but it's a little bit higher than this. So I really wanted an E. It could happen. All right. I'm looking at these, I'm thinking, okay, these are very, very low. Imagine if I said there's an 8% chance of rain today. Are you bringing your umbrella and your jacket and clothing that will be receptive? No, you might be thinking it's probably not going to happen. But could it happen?
Yes.
Yeah. So.
Like when it's going to snow.
Mhm.
10% chance of snow.
Yeah. Yeah, and I've also had, being in Denver, because in California where I grew up, we never had snow. I said that one time, which was glorious. Did I tell you about it?
No.
Okay, it was awesome.
Oh yeah, I remember that time.
We were playing outside our church. We were playing football for some event. And it was a cold day, so we had our sweaters on. And we're throwing the football around. And I remember we're just playing our game, and all of a sudden, we see this stuff coming down. And I'm about I had to have been 14. 14, I see these things coming down. I'm like, oh, it's rain. It's going really slowly. I reach out my hand, and this little flurry comes down, and it lands, and it disappears. And then it's landing on us, and we're like, guys, it's snowing. We're like, oh my goodness, it's snowing. I've never been in snow like it. I was so excited. But I didn't know what it mean. I didn't know what it meant for snow to stick. It didn't stick. It just disappeared. But that was in California, right outside the Bay Area. So we don't get snow, but except for that one time. Wow, those are the times.
Yeah.
Okay. Anyway, in Denver though, we would have the forecast saying 80% chance of snow. And it's saying you're going to get maybe 10 to 12 inches of snow. I'm thinking, as a teacher, we might not have school the next day. So I'd wake up. And I remember doing this, especially at the beginning. Oh, man. I can't believe it. What happened? What do you think? So I look around. No snow. Or it's coming down, it's not sticking. 80% chance, and it didn't happen. So just because it's high doesn't mean it happens. Just because it's low doesn't mean it doesn't happen. So going back to the Warriors, you know their percentage of losing the finals 2 years ago was? It was down to 3%. 3% of losing. They lost. It happened right before my eyes. Father's Day with Ezra sitting on my lap, and all I asked him was, please give me this game, Ezra. And I've been upset with him ever since. No, I'm just kidding. I still love you, Ezra.
What about when it's 100% chance of rain and then it doesn't?
Good. And have you ever seen 0% chance of rain?
Yeah.
Okay, here we go. Thank you for that segue into this. Here is our spectrum of probabilities. If there's a 0% chance or 0 out of some number, that means it is impossible for it to rain, snow. For example, like the probability of it getting to 130 degrees here in Greenville, South Carolina. As much as climate people say, not going to happen. 0%, impossible. It's never happened, won't happen. Okay? Now that I say it, well, it's just like 0.00001 and it happens, my fault. Okay, but anyway, that's what I'm going with. And the greatest probability you can ever have is 1. And that is certain. We call it certain. It will happen. So if it's at 100%, which is what as a decimal number, what's 100%? It's this big fat 1. It is certain. It will happen. And our probabilities are going to be really anything between 0 and 1. Right? Wasn't 1/2 right here? And then 2/3 was over here somewhere. And then 9%, 8% are somewhere over here. Almost all our probabilities fall between impossible and certain. So let me give you a probability of something it's not likely to happen. Ready? I'm playing Chutes and Ladders, and I really am looking for that 7. So I roll that die. What do you think happened? And I asked Ezra, come on, you got to give me another chance. So I take the die. He's like, Dad, you can't. Okay. And I roll it.
That's a 6. You're so close.
It fell off the table, so I got to pick it up. Redo.
That's a 6.
You touched it, Ezra. I got to take it again. Okay. What is the probability of me getting a 7 in Chutes and Ladders with a regular 6-sided die?
0%.
It's 0 out of 6. There are 6 possibilities, aren't there? But none of them give me a favorable outcome. That's impossible, right? I mean, I hope you guys understand. All right, ready? Ezra, on the other hand, he's laughing at me. Because he's like, yeah, you go ahead, try again. Thanks, Ezra. Okay, but now it's his turn. All he has to do is get 1 or any other number. So he does it. He gets cocky with his dad. I'm thinking when he's older, I'm just imagining. If he's anything like that. Can you blow on it, Dad? Okay, and then he throws it in the air, lets it fall down. And I catch it. Because I'm like, oh, wait, you can't throw that high. It's illegal. So put it back down. You guys just give it a nice toss. And what happens?
It lands on his corner.
It lands on a 7. Oh, my. He does. Okay. There are still 6 outcomes. He needs anything 1 or greater. And he gets it. It's going to happen no matter what. It's certain it will happen. There's nothing that I can do. Well, is there anything I can do?
Yes, you can throw it.
Can I break the die?
Yes.
Can I throw the board? Honestly, I'll be honest with you guys right now. Let me give you the application here real quick. I'll do it real quick because I know you guys want to get started here. The application is this. I've played so many board games in my life, and I'm competitive in almost everything I do. I'm too competitive. So I'm playing with a group of friends or family, whatever, and one-on-one die rolling. Anyway, we play the game, and I'm trying to win, and I need Settlers is one that comes to mind. I need that 8. I need it. It's going to give me my or. I need the or. So someone rolls it, or I roll it, and I don't get it. You gotta be kidding me! It's an 8. The probability is so high for an 8 compared to us. Like a 2 or what's the other one? The highest.
6 is really
12. Those aren't going to happen. The 8 could happen and should happen in my mind most of the time. Yeah. Oh, okay, yeah, the other ones. So I get mad. I'm like, and then someone else collects their, I don't know why, they call it sheep sometimes, but it's really, you get the wool, whatever it is. I get mad, and then this is the opposite. I'm winning, ready to win this game. And someone rolls, yes! That's my number. I win. And I don't say it out loud nowadays. I just keep it inside. I'm like, yes, you got owned. And I just say it in my heart. And you know what I think to myself? I'm taking credit for something I had no part in. What did I do to make that die get to the number I wanted or didn't want? And what did I do to make that happen where it was negative? I did nothing for it to happen. But then I think to myself, but didn't my response have everything to do with me? Yeah, it has everything to do with me. So I think to myself, I should be thankful when God gives me a good number. Really, in a game. Thank you, Lord, for giving me that. I like winning. Thank you for doing that. But, Lord, thank you that this person, that's the worst. You won and I lost. Thank you for that. No, thank you, Lord, for I didn't win this time. Help me to have a good attitude, because it doesn't always happen that way. Now, think of it with less probable things like basketball, volleyball, soccer. You have an effect on that ball. You have an effect on what happens over there. You have an effect on what decision you make. But even then, is it all on you? No, it's never all on you. Even if you were sitting there writing a number, yeah, you don't have it. But you don't have the full control, because God is the one who has control. He's the one who gave you all those talents. So here, for God, does he look at it and say, ooh, that's going to be very certain? Impossible. No, he sees things the way they're going to happen. He knows exactly what I'm getting on that next die roll. He knows exactly if that shot's going to fall or not, and if that team's going to lose or not, and that's his sovereignty. Okay. Sorry, but let's keep moving here. I'm done. Let's look at odds real quick. This is actually very easy if you understand probability. Odds. And odds is going to be the number of successes. The number of successes. Successes.
Over the number of failures.
It's going to be colon the number of failures. The number of failures. What do you mean by a number of fails? Okay. Let's look at this real quickly. I won't take up too much time because I think you guys get this pretty well. Okay, I'm going to go back to probability of heads. Okay, let's just go probability of heads. What's the probability of landing a heads on a coin toss? It's how many possible? 2. How many are favorable? 1. So it's going to be 1 over 2. You guys okay with that? Okay, now I'm going to ask, what are the odds of getting a heads? What are the odds of getting a heads? Okay, how many, for one toss, how many successful outcomes are there? How many successful? There's one successful outcome. 1. How many failing outcomes are there? 1. So you know what the odds are? 1 to 1. You say 1 to 1. Those are the odds for getting a heads. It's 1 to 1. You can say 50-50, but we use something to something. Yes, ma'am? It's a ratio. And in fact, how many of you see that that's a ratio?
Me.
How many of you see that's a ratio? How many of you see that this is also a ratio? Okay, good. And that's what the whole chapter is about, right? Ratios and probability, ratios and proportions. Yes, sir?
That's like all they use for horse races, right?
Yeah, they use odds a lot. Yeah, the odds of this horse winning are blah to blah.
But when we play what are the odds? It's not doing it right, because we're not saying like when the one we're saying 1 and 2.
Gotcha. Like you're doing probability then. Yeah, so you're playing the probability game. No, that's good way to think it. Yeah, what's the prob? Okay, let's look at a couple problems so I know you know how to do these. On page 230, number 10. If you roll a die, what are the odds of getting, for number 10, a number greater than 2? So, I need 2 numbers separated by the colon, 1 number describing how many successes when you roll a die for that outcome, and failures for that outcome. So, how many successful outcomes are there for a number greater than 2 on a die roll? So, how many successful? 4, right? You can get 3, 4, 5, and 6. Those are good. How many unsuccessful or failing outcomes?
6.
Failing outcomes are 2. 2 failing outcomes.
2.
So what is this ratio simplified? Bless you. 2 to 1. It's a 2 to 1 odds that you're going to get a number greater than 2. That means for every 2, there will be 1 unsuccessful. Every 2 successful, 1 unsuccessful. That's all it means. All right. You should be able to see that, hopefully, with that problem. Number 11. This one's tough because they say not a 3. So you got to think of it. I don't want a 3. I don't want to help that person get their resource. I don't want a 3. So if you're rolling 1 die, which I know it's different from that, how many are not going to be 3? 5. That's success. How many are going to be 3? 1. So your odds of not getting a 3, 5 to 1. That would be your answer right there. Okay, number 12 is my favorite because it makes you think. Someone read number 12 for me. Riley.
If the probability that an event will occur is 3 to 7, what are the odds that the event will not occur?
And do you notice what they do with the not? They italicize it, so that's significant. All right, number 12. The probability of an event occurring is 3/7 or 3 to 7. Okay? What are the odds that it will not occur? So you got to think about it. Odds. I want odds, not probability. I want odds of it not happening. So how many favorable outcomes for it not occurring? Because you got to think differently. Yes, sir. 4. Okay, 4. Now, I thought favorable was 3. But this is of it happening. What's the probability of it not happening? 4/7, right? So that's how you get the 4. How many failing outcomes are there if you don't want this to happen? I think I heard 3. It's 4 to 3. Okay, ready, guys? If you know, and this one's kind of a tough one because it's not, but do you guys see that the probability of it not happening would have been 4/7 of it not happening? If it was 3/7, now not happening is 4/7. Do you see where I get the 4? And do you see, how in the world would you describe how I got that 3? Yeah.
What did you say?
Wha-
What's the probability? Like 3 is the possible outcome.
Yeah, and all you have to do is 7 minus 4 is? There you go. 7 minus 4 is 3. That's it. Odds of it not happening 4/3 or 4 to 3. Okay, your homework tonight. Oh, the revolt begins. All right. 13 to 30.
That's like impossible.
Josh, you could give you 13 to 40 if you want.
Walker, what a great idea. No. I never thought of that. No, you guys go ahead. They're not that hard. But just read it carefully. Yeah, all. Read it very carefully. Swivl, we will stop.